Now we're going to talk about collisions. There can be a lot of really complicated collisions. We're going to start simple and just think about two masses. When two masses interact impulsively, and you know what that means now, big force, short time, and they exchange momentum. We're going to illustrate all of our simple two-body collisions here with these cars. They're fairly frictionless, so we don't have to worry about friction too much, and we'll look at what happens when they crash into each other. Okay. Now to get started, we really want to start even simpler than that. Let's start by saying we have two identical masses. So same mass. So here they are. Here's one with mass m, and here's another with mass m. Identical. One approaches at vi, the initial velocity. So there we go. That one's moving at vi, right? And the other one is still. One approaches at vi, other is still. It is not moving like that. And the question is, after they interact impulsively, what is going to happen? We don't know. How are they going to move? So the question is, what happens? That's the exciting part. I don't know what's going to happen. One thing I do know is they're going to conserve momentum. That's the one thing I know for sure. So let's see how you could conserve momentum here. So we're going to do it mathematically later. Now let's just think our way through it. The initial momentum was m times vi. So one way you could conserve momentum is you could have this one stop and this one go at vi. Right? That would conserve momentum. But there's other things that could happen and still conserve momentum. You could have this one move forward at vi over 2, and this one could move forward at vi over 2. Right? No reason that couldn't happen. This one could move forward at vi over 4, as long as this one moves forward at 3/4 vi. Because then it's still going to be m times v over 4 plus m times 3 v over 4 is m times 4 v over 4, which is mvi. So the momentum would still be conserved. You could even have this one bounce backwards at 2 vi, as long as this one bounces forwards at 3 vi. Because then the final momentum would be m times vi. So as you can see, conserving momentum is important, but it's not enough. We need more information to decide which one of these is going to make it happen.